getting good quality data is at the core of data analytics and machine learning. And websites are an undeniably good and sometimes only source for these. These days, many websites are dynamic and require a high level of interactivity to get down to the actual data. And this is where Selenium and Python combine to help us out. In this first module, we'll be exploring Selenium with Python. Before we get into the nitty-gritty of the module, let's quickly go over some things that you need to know. Right out of the gate, this course will assume a basic to intermediate level of Python programming. You'll also need a basic understanding of HTML and CSS so you understand how a web page is structured, which will make the whole course make more sense. It'll also be helpful if you're familiar with some fundamentals about data analytics, which will help you understand the need for the things we do during the course. We'll go about the course in the following way. First, I'll introduce a concept to you. Then, we'll get a little bit more deeper into it and you'll get to see the nuts and bolts of it. Lastly, we'll have a practical implementation of what you've just learned. Here's what we'll cover in the first module. For starters, we'll get into what exactly scraping dynamic websites mean. How is it different from scraping normal, static websites? Then, we'll dive into Selenium for a little while. We'll have a brief overview of what it is, what are its components, and its use cases. Then, we'll go into more detail about one of Selenium's tools, the WebDriver. We'll have 2 demos for this module. In the first one, I'll walk you through all the libraries and packages required to use Selenium with Python, which is what we'll use for the duration of the course, and how to go about installing them. In the second one, we'll use the WebDriver to open a web page. Let's get started. Let's start from the beginning. What does scraping dynamic websites even mean? Answering this would also answer the question, why take this course at all? Let's begin to do just that. We'll start by asking the primary question, what is web scraping? Web scraping can be thought of as the process of extracting information and data from a web page into a structured format for further analysis. The techniques and tools to perform web scraping depend on the type of content on the web page being scraped. Content can be broadly classified into 2 types, static and dynamic. Static content means the code and consequently the content is fixed. It is incapable of change or action on the fly unless the owner of the page changes the code. Whatever you see in the View Page Source section is exactly what you get. It remains the same for every viewer of the site. Examples of static web pages would be plain government websites, plain blogs, documentation for software packages, etc. Pages with dynamic content contain dynamically rendered components and information that changes based on many factors, such as who the user is, the time of day, chosen language, etc. Websites with infinite scrolling such as Twitter, that is dynamic content. An e-commerce website with a next page button that you have to click on to get to more products and offers, that is dynamic as well. Now, tools which help us scrape content from static web pages aren't sufficient when dealing with dynamic content. That is where Selenium comes in. And how to scrape information from dynamic websites is exactly what we learn later on in this course. But first, let's have a look at what Selenium is and what it has to offer. Selenium is a set of tools and libraries that automate web browser actions. That is what it does. It automates web browsers, and what you do with it is entirely up to you. Selenium uses a WebDriver package that can take control of the browser and emulate user-oriented actions to trigger desired events. Events such as clicking buttons or links and even scrolling. It is free and open source and works across Windows, macOS, and Linux. It also supports plenty of language bindings such as Python, Java, Ruby, Scala, C#, etc. so you can write scripts in whatever language you're comfortable with. There are 4 components to Selenium. Selenium IDE is a simple record and playback kind of tool which comes as an add-on for Mozilla Firefox only. It is used for prototype testing. Selenium RC or Remote Control was the first tool of the Selenium suite. It is a test tool that allows you to write automated web application UI tests in any programming language against any HTTP website using any mainstream JavaScript-enabled browser. It is known as Selenium 1.0. Then comes the Selenium WebDriver, which is what we'll be using throughout this course. It is probably the most important tool of the Selenium suite. We'll dive deeper into this in the next video. And finally, the last component of the Selenium suite is the Selenium Grid. It is used for parallel or distributive testing, which means it allows us to execute test scripts on different machines at the same time. Where is it used? Like I said, Selenium automates web browser actions, and as such, scripts can be made to automatically perform the same interactions that any user can perform manually. The biggest use case would be automated web application testing, and that is what it was originally intended for. But because of its flexibility, it is also used for other purposes, such as scraping dynamic web pages, which is what we are going to do. Now, let's get into what a Selenium WebDriver is. The biggest change in Selenium recently has been the inclusion of the WebDriver API. What does it do? It drives the browser natively, just as a user would, either locally or on a remote machine using the Selenium server, marking a leap forward in terms of browser automation. WebDriver is designed to provide a simpler, more concise programming interface in addition to addressing some limitations in the Selenium RC API. Selenium WebDriver fits in the same role as RC did and has incorporated the original 1.x bindings. It drives the browser much more effectively and overcomes the limitations of Selenium 1.x, which affected our functional test coverage like the file upload or download, pop-ups, and dialogues barrier. It refers to both the language bindings and the implementations of the individual browser controlling code. This is commonly referred to as just WebDriver or sometimes as Selenium 2. So essentially, Selenium 1.0 plus WebDriver is Selenium 2.0. Selenium WebDriver was developed to better support dynamic web pages where elements of a page may change without the page itself being reloaded. And based on your browser, it has many classes to choose from, such as the Chrome driver, Firefox driver, Safari driver, etc. Here's a diagram showing the architectural representation of the Selenium WebDriver. It has 4 basic components: the Selenium language bindings, JSON wire protocol, browser drivers, and real browsers. Selenium developers have built language bindings or Selenium client libraries in order to support multiple languages. For instance, if you want to use the browser driver in Java, use the Java bindings. All the supported language bindings can be downloaded from the official website of Selenium. JSON, or JavaScript Object Notation, is an open standard for exchanging data on web. It supports data structures like object and array. JSON Wire Protocol provides a transport mechanism to transfer data between a server and a client. Selenium uses drivers specific to each browser in order to establish a secure connection with the browser without revealing the internal logic of the browser's functionality. The browser driver is also specific to the language used for automation such as Java, Python, etc. When we execute a test script using WebDriver, the following operations are performed internally. HTTP request is generated and sent to the browser driver for each Selenium command. The driver receives the HTTP request through the HTTP server. The server decides all the steps to perform instructions which are executed on the browser. Execution status is sent back to the HTTP server, which is subsequently sent back to automation script. In the first demo of the course, we are going to install all the libraries and packages required for the entirety of the course. We need 4 things: the Selenium package, the WebDriver for your browser, the Beautiful Soup package, and Jupyter Notebook. You can go to this website for instructions on how to install the first 2 things. For installing Selenium, all you need to do is go to your terminal and type in pip3 install Selenium. Selenium requires a driver to interface with your choice of browser. And if you go down on the same page, you can see the various drivers for different browsers. I use Chrome and I'm on the Mac OS, so that is the route I'll show today. But it is very similar on other browsers and operating systems. We'll click on this link, which takes us to this page. Based on your Chrome version, you'll need to click on the correct link. You can see I have version 74 and change, so I'll be clicking on this link. And again, download the correct driver based on your OS. Go ahead and unzip the file. You should get an executable file called Chrome driver. To use this, you can either make it accessible via the path variable of the operating system, or in case you get errors doing that, you can directly specify the location of the Chrome driver. This will become more clearer in the next demo. And finally, we'll install Beautiful Soup. Similar to the Selenium package, typing out pip3 install Beautiful Soup 4 on your command line or terminal should do the trick. We'll also install Jupyter Notebook, which is something most of you will be familiar with if you've dabbled in data science. You can get it by installing the Anaconda package for Python 3 from this link. This, in addition to installing Jupyter Notebook, also installs a bunch of very useful packages for data science. If not, you can always use pip3 install Jupyter on your terminal or command line. In this second demo, you'll get to learn how to open a web page using the WebDriver. This demo serves 2 purposes. The first is, as stated, you'll get to see how to open a web page with the WebDriver, which is the first step to scraping a dynamic web page. The second is, you'll get to see if all of your package installations from the previous demo work correctly and are in place. So, let's get to it. For this demo, we'll try to open the Pluralsight website using the WebDriver. As you can see, all the code you'll need for this demo is pre-written. Let's go through it step by step. First, we'll import the WebDriver from Selenium. Then, we'll initialize the Chrome driver. Here, in case you've made the Chrome driver accessible via the path variable of the operating system, this is all you need to type. If you haven't, or if you run into errors doing that, you can simply manually specify the file path like this. This is the command to open up the web page. As you can see, once it is executed, a Chrome tab opens up displaying the site. And if you'd like to close the web page, this is how you do it. While doing this, you can also specify that you want certain things to happen a certain way with Chrome options. You can add arguments such as you want the website to open up in an incognito tab, or you want the window to be a certain size, etc. Here, we are adding the argument for a headless browser. What is a headless browser? Headless browsers are web browsers without a graphical user interface or GUI, and are usually controlled programmatically or via command line interface. In simple terms, you wouldn't be able to see the page opening up like you did before. There are many reasons to use headless browsers, not the least of which is the performance boost you receive from lacking the GUI. And this will particularly be noticeable in case you're opening up several windows with multiple tabs. Also, it helps to avoid any user action on the browser during the scraping process, which can interrupt the process flow and cause unexpected behavior. As before, you initialize the driver with the options and fetch the page, but this time you don't see it open up. That's it for this demo. We'll get into more advanced territory with the demo from the next module. In this module, we had an overview of what web scraping is with regards to static and dynamic content. We then had a brief look at Selenium, its use cases, and its components, the IDE, RC, WebDriver, and the grid. We then went deeper into the Selenium WebDriver, learning why it was developed and its advantages over the RC. We also took a look at its architecture. We had two demos in this module, one showing the installation of the required packages for the course, and the second one showing how to open a web page with the WebDriver.